In September 2017, a time when deep learning, the mainstream algorithm of artificial intelligence, came to a climax of media heaping to a point of being deemed almighty, the inventor of deep learning, Professor Hinton of the University of Toronto, suddenly announced to the world that his dream of the Boltzmann mechanism was shattered, and the black box problem of deep learning could not be solved. So the algorithm must end. Overnight, the field of artificial intelligence fell into the trap of an algorithmic vacuum. In this dark hour for the academia, we developed and put forward the SDL model, a new generation of artificial intelligence, which attracted great attention from the artificial intelligence circle. More amazingly, a mere half-year later, our team made a remarkable breakthrough in advancing our autonomous driving technology from computational model to real car application. Safety is always people's biggest concern for autonomous driving. Can the SDL model solve this problem? "30 mannequin models are placed on the experiment road to simulate the crowd. It is no easy job for even a human driver to navigate through this maze safely. Can the autonomous driving system using the SDL model accomplish this task? Amazingly, the autonomous vehicle made it out of the maze with great ease. Guided by binocular image recognition, the SDL model can choose the best route like human and execute a series of compound controls, such as speeding up, slowing down, and turning, demonstrating that autonomous driving can be as safe as human driving. Facing relatively static objects, autonomous driving based on the SDL model gave a nearly perfect solution. But what about vehicles running normally on the road? Can the SDL model also navigate its way through safely? Once again, performance of overtaking in the autonomous driving system of SDL model also made us proud. When facing complex traffic conditions, the machine consciousness of the SDL system, like human, can command the control unit instantaneously and execute complex operations swiftly, such as overtaking and changing lanes. The decision-making problem that troubled many international companies have been completely solved by our team. Why traditional artificial intelligence algorithm failed at autonomous driving? Comparing data of the two left turn experiments, we found that the traditional control theory shows great randomness in driving trajectory control for autonomous driving, and therefore often leads to deviation. In contrast, the SDL system uses the Gaussian recognition based on machine learning, realize the driving trajectory almost identical to that of human drivers. This means the SDL system has achieved a control performance that takes international companies nearly 10 years to accomplish in a matter of just a few days. Traditional sensing systems can only capture and recognize 2D images in grayscale and have poor recognition performances at night, while the SDL model can extract targeted images directly, like human eyes. Thus realize a breakthrough in lane line recognition at night. The SDL model that our two research teams put forward is mathematically called an algorithm with a Gaussian process with maximum probability. When facing complex, non-linear and random objective functions, the SDL model can have human-like consciousness and realize the Turing driving technology beyond human capabilities through perception, decision-making, and control. And we attribute our achievement to our dynamic, courageous, and an innovative team. Autonomous driving system is just one of the application scenarios for SDL, which can be used independently for image recognition, robot decision-making, and various industrial controls. As a universal artificial intelligence model, SDL can make up the vacuum situation where the current mainstream algorithms are negated. Being the core technology of the new generation of artificial intelligence strategy, it will surely make its contribution to human development.